Welcome to section 5.3. We're going to be talking about solving trigonometric equations. So before we start, you want to have a note card or something. Keep in mind, when we have a pi over 6, we're at root 3 over 2, 1/2, and the tangent is root 3 over 3. Pi over 4, root 2 over 2, root 2 over 2, and the tangent is 1. And for pi over 3, we're at 1/2, root 3 over 2, and the tangent is root 3. Also keep in mind, here we are at 0. We're at 1, 0. At pi over 2, we're at 0, 1. At pi, we're at -1, 0. And at 3 pi over 2, we're at 0, -1. In quadrant 1, your signs are positive, positive. In quadrant 2, your signs are negative, positive. Quadrant 3, negative, negative. And in quadrant 4, positive, negative. Tangent of theta is undefined at pi over 2 and 3 pi over 2. When we're looking at the inverses, we're looking at, for sine and tangent, quadrant 1 if they're positive, quadrant 4 if it's negative. For cosine, we're looking at quadrant 1 and quadrant 2. So keep that in mind. Now, there's a lot going on here. So you're going to need to use this for reference. Now, looking at 2 sine of x equals 1. We're going to isolate the sine of x. So we're going to divide both sides by 2. So we get that the sine of x equals 1/2. Now, sine of x equals 1/2. If you look when the sine of x is 1/2, that's the y value. Sine of theta is our y, cosine of theta is our x. So when is our y 1/2? At pi over 6. Now, sine is not just positive in quadrant 1. Sine is also positive in quadrant 2. So we have pi over 6, that's our quadrant 1, and for quadrant 2, that's 5 pi over 6. So there's our two solutions. So for our solutions between 0 and 2 pi, we're at pi over 6 and 5 pi over 6. Now, we also have what's called the general form. Now, the general form is all of the solutions, all possible. Remember, this comes from the unit circle. It's a circle. So kind of going down here, let's say this is pi over 6. Now, we can just keep going around that circle. So that's going to be pi over 6 plus 2 pi. We can go around again. And then we're at pi over 6 plus 4 pi. And plus 6 pi, we can write that as pi over 6 plus 2n pi. That's going to give us all of the possible solutions. We also have the 5 pi over 6. Once again, we can just keep going around. So that'd be 5 pi over 6 plus 2 pi and plus 4 pi. So we could write that as 5 pi over 6 plus 2n pi. Those would be our general solutions. So x equals pi over 6 plus 2n pi. 5 pi over 6 plus 2n pi. Those are all of the possible solutions. So we have two types. We have the from 0 to 2 pi just in that first unit circle, and then we have all of the solutions. So when you're solving these, some things to consider. Isolate, use your different algebra techniques, and then write your answer as a general solution. We're going to write them as both, between 0 and 2 pi and the general. So let's go to the next page. We want to isolate. So I'm going to add the sine of x to both sides. And I'm also going to subtract the square root of 2 from both sides. So I get 2 sine of x equals negative square root of 2. Divide both sides by 2. The sine of x equals negative root 2 over 2. Now, sine is negative. When I see that negative, I know for sine I'm in quadrant 3 and quadrant 4. Because sine is positive in quadrants 1 and 2. When I see that root 2 over 2, I know that x equals a pi over 4. Now, to get myself into quadrant 3, we have to have a 5 pi over 4 and a 7 pi over 4. Those are our solutions from 0 to 2 pi. That's just in that first unit circle. Now, the general solutions. X equals 5 pi over 4 plus 2n pi. And x equals 7 pi over 4 plus 2n pi. That's going to give us all of the solutions. Those are our general solutions. All right, let's try another one. Problem number 2. Same thing, very similar. Add sine of x to both sides to isolate. I'm going to add root 2 to both sides. So I get 2 sine of x equals the square root of 2. Divide both sides by 2. The sine of x equals root 2 over 2. Now, the sine is a positive. So when I see that, I know I'm in quadrant 1 and quadrant 2. Now, x equals. When I see a root 2 over 2, I know my denominator is going to be a 4. So I'm some pi over 4. So quadrant 1, it's just pi over 4. In quadrant 2, it's going to be 3 pi over 4. Those are my solutions from 0 to 2 pi. And then our general solutions. X equals pi over 4. And to get back there, we're going to add a 2 pi or a 2n pi to keep going around the circle. And also x equals 3 pi over 4 plus 2n pi. There's our general solutions. Let's keep working with these. You'll see some similarities. Number 3. We want to isolate that sine. So we're going to subtract 1 from both sides. 2 sine of x equals negative 1. Divide both sides by 2. So the sine of x equals negative 1/2. Once I see sine being a negative, I know I'm looking in quadrant 3 and quadrant 4. All right, so now, when the sine is a 1/2, that's when our angle is going to be a pi over 6. Now, I need to know what pi over 6 it would be, to get ourselves into quadrant 3. And to get ourselves into quadrant 3, it has to be a 7 pi over 6. To get us into quadrant 4, it has to be an 11 pi over 6. Those are our solutions from 0 to 2 pi. That's just in that first unit circle. For the general solutions, all of the solutions that are possible, 7 pi over 6 plus 2n pi, 11 pi over 6 plus 2n pi. Those are our general solutions. Those are giving us all of the solutions that we'd ever have in that form. All right, let's go to problem number 4. Isolate that cosine of x, subtract 1. 2 cosine of x equals -1. Divide by both sides by 2. The cosine of x equals -1/2. All right, so now cosine equals a negative. Don't forget, all students take calculus. Those are where the ratios are positive. So in order for cosine to be negative, it's got to be in quadrant 2 and in quadrant 3, because cosine is positive in quadrants 1 and 4. So now, x equals. So when cosine equals a 1/2, that's going to be at our pi over 3s. Now to get myself into quadrant 2, a 2 pi over 3. To get myself into quadrant 3, it's a 4 pi over 3. There's our solutions from 0 to 2 pi in that first unit circle. Now for our general solutions. What we have here is that x equals 2 pi over 3 plus 2n pi. And x equals 4 pi over 3 plus 2n pi. And there is the general. That would be all of the possible solutions in that form. Looking at problem number 5. Once again, isolate that cosine of x. So we're going to add cosine of x to both sides. And we're also going to subtract the square root of 2 from both sides. So we get 2 cosine of x equals -√2. Divide both sides by 2. The cosine of x equals -√2 over 2. All right. Once again, cosine is negative. We've got to be in quadrants 2 and quadrant 3. Now, for cosine to be a √2 over 2, we know it's got to be something pi over 4. So to get us into quadrant 2, it's going to be a 3 pi over 4. And to get ourselves into quadrant 3, 5 pi over 4. There's our solutions from 0 to 2 pi. Now to get our general form, x equals 3 pi over 4 plus 2n pi, and x equals 5 pi over 4 plus 2n pi. And there's our general solutions. I'll be back again with another video talking about tangent as well, and that will be there just because tangent's a little bit different than the sine and cosine. All right, I'll see you in the next video.